Hey kiddos! Today we're going to be beginning our new unit on radicals. So we're going to first start off with how to simplify radicals. So, some guidelines. Number 1. The item under the radical sign, remember the radical sign is the square root sign, okay, is called the radicand. So if I have the square root of 5ab, then 5ab is the radicand. Number 2. Items under a radical symbol may be multiplied or divided. So if you have square root of AB, it is the same thing as saying square root of A times the square root of B. Or if you have the square root of A divided by B, it's the same thing as saying square root of A divided by the square root of B. Number 3, the radicand cannot be negative. So, square root of -4 is not allowed because this results in a non-real value. Number 4, the radicand cannot contain any perfect square factors, so meaning you cannot leave it as square root of 16. And the reason why square root of 16 is not allowed is because 4 is a perfect square factor of 16. Number 5, the radicand cannot be a fraction. So the square root of 5/4 is not allowed because the radicand is a fraction of 5/4. You'd have to break it down and simplify. So you can't have fractions. And number 6. Let me scroll this up. No radical symbol can be in the denominator. So 1 divided by the square root of 2 is not allowed because the denominator has a radical. And that's not cool. Be sure that you know your perfect squares. So here is a complete list. So when we talk about perfect squares, it's basically like 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, so on and so forth, so forth. So obviously it goes on forever. So here you have 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. And notice, yes, this list does go on. Okay? But you need to make sure that you know your perfect squares. It makes dealing with radicals a lot easier. For the next examples, we are going to create a factor tree. So, some of you may have learned what is it called? The birthday cake method is basically the same thing that I'm doing. I just like trees better than birthday cake. So, don't judge me. Notice what I started off with, 2 numbers that multiply to 45, and I got 9 times 5. 9 times 5 is 45. So now I'm going to try and break down those numbers as low as I can. I know 9 breaks down to 3 times 3. 5 is just going to be 5 times 1, so I don't really need to do anything to it. Now what I like to do is I squiggle out what I've broken down because I don't need those values anymore. What's left over is what I'm going to be dealing with. Now I'm looking for pairs. So I got a pair of 3s, and I got a 5 that's left over by itself. My pairs go outside of the radical sign. What's left over goes inside. So got another one. 66. 2 numbers to multiply to 66. 33 times 2. 33. 3 times 11. 3 can't be broken down any further. 11 can't be broken down any further. And 2 can't be broken down any further. So squiggle those out so I don't get confused. And notice I have no pairs. So all of these are going to be underlined. And remember, what's left over or what's underlined here goes back under the radical. And to figure that out, all you have to do is, what's 3 times 11 times 2? Well, that gives us 66. So notice the square root of 66, or 66 can't really be factored into anything. So that's what you would be left with. Notice for these examples, I didn't really quite follow my own directions very well because it says just to create the factor tree. What we did was we created the factor tree and we simplified. So, kudos to us. All right, here we go with some more examples. Example, Tress 3. Square root of 42. So here now we're officially actually simplifying radicals, okay? So that's why you see square root of 42. So to do that, a factor tree is what's going to help me simplify it. So I got 7 times 6, which is 42. 6 I know can be broken down to 3 times 2. I can't break down 7 anymore, 3 or 2, so that goes away, that goes away. Notice I have no pairs, so my answer is going to be a square root symbol. It's going to have it in there. And it's going to be the 7 times 3 times 2, which is 42. So notice the square root of 42 cannot be simplified, so that would be the answer, right? Square root of 66. 33 breaks down to 3 times 11. Notice I have no pairs because I can't break down those numbers anymore. So the answer is square root of 66. You cannot simplify any further, so that would be the answer, okay? So, next one. We have a square root of 128 divided by 5. Well, remember, one of our guidelines states that when you have a fraction or division going on, that you can actually break it down like this. Square root of 128 divided by the square root of 5. So, we have basically 2 problems in one. So, let's deal with the square root of 5. Well, the square root of 5, after I break down 5 to 1, can't really break that down any further, so it's actually going to stay square root of 5. That's a horrible looking 5. Sorry. It's a little better. All right, so now let's deal with the 128. I know that 8 times 16 is 128. I know 8 breaks down to 4 times 2, and 4 breaks down to 2 times 2. 16. 16 is 8 times 2. 8 breaks down to 4 times 2, and then that 4 breaks down to 2 times 2. Well, we got a lot of 2's. So remember, I'm going to squiggle out everything that we've broken down because I don't want to accidentally reuse any of those numbers. All right, now let's look for pairs. Let's see. There's 1 pair. There's 2 pair. 3 pair. That's left over. So we're going to multiply the pairs. So that's 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So 8 goes on the outside. And what goes back on the inside is what we had left over, which is this 2. So when we rewrite our example here, you get 8 square root of 2 over the square root of 5. Technically, one of the rules states that we are not allowed to have a radical in the bottom. I'll be going over, we're going to leave it like this for now, okay, because I just wanted you guys to practice simplifying. We're going to leave this problem for now, but note that this is actually technically not the finished answer, okay, because we should not have a radical in the bottom. Example 6, 21. 7 and 3. 7 and 3 can't be broken down any further, so the answer is square root of 21. All right, so 15. 3 times 5 gives me 15, but notice you can't break down either one of those numbers, so square root of 15 can't be simplified. Let's look at another fraction. We got square root of 63 over 8. Okay, so let us break them down. So it's like 2 problems. So we got square root of 63 divided by square root of 8. So let's break down 8 first. 8 is 2 times 4. And then 4 can be broken down to 2 times 2. So let me squiggle those out. I have one pair of 2's, and then I got a 2 left over. So that gives me 2 square root of 2. Now let's go over to 63. 63 is 9 times 7. Okay, those numbers multiply to 63. I know 9 I can break down to 3 times 3. 7 I cannot break down any further. All right, so I got a pair of 3's and an extra 7. So this would be 3 square root of 7. So when we write our answer here, you'd have 3 square root of 7 over 2 square root of 2. Now for today, we're going to stop here. Remember, this is not completely simplified though. As you can see, you have a few to do on your own. Number 1, number 2, and number 3. Please make sure that you use the concept of the factor tree, or if you prefer your birthday cake method, if you like it, it's basically the exact same thing as a factor tree, and that's totally fine with me. If you have any questions, please write them down so that way I can address them in class the next day.